is new stuff. So this rational zero theorem. We'll read through the complicated words, and then we'll simplify it to something that's a whole lot easier than all of those words. Okay, let f of x be, and this looks terrible, a sub n x to the n plus a sub n minus 1 x to the n minus 1. All that means is that's just a generic polynomial. So don't be scared by all the letters and subscripts and powers like that. They're just saying a polynomial. Let f of x be a polynomial. In fact, then it says represent a polynomial function with integer coefficients. So no fractions, no decimals. If p over q, which is weird because they haven't told us what p and q are yet, but if p over q is a rational number in simplest form and is a zero of that polynomial, then p is a factor of a0. a0 is the last term. Q is a factor of an, which is the first term, or the first coefficient, I should say. This is worded kind of weird, but what they're trying to say is all of your zeros, all of your rational zeros, so not the i's or the square roots, but all the rational zeros come from factors of the last term over factors of the first term. Let me write it out easier. Possible rational roots. Possible irrational roots are factors of the last coefficient over factors of the first coefficient with a plus or minus on there. Could be either one. So this kind of goes back to a time in the land before calculators. If you didn't have a calculator to find the zeros and you're trying to just figure out what the zeros of this first example are, how in the world would you know where to start? But the rational zero theorem, the possible rational roots, tells you where to start. Let's back up and talk about some things that we know. What degree is that polynomial? 4. Which means how many zeros does it have? 4. So there's only 4 zeros, but we don't know what there are. I can't factor that thing. So let's look for a list of possible rational zeros. And again, it's factors of last over factors of first. Factors of the last term over factors of the first term, with a plus or minus on there. Okay, so factors of the last term. The last term is 2. So what are my factors of 2? 1 and 2. My only options there. Factors of the first coefficient. First coefficient is 6. 2, 3, 6, 1 is fine, and you can list them in whatever order you like. And so I'm glad you said it that way. Some people will list them like by how they're paired up, like 2 times 3 goes together, 6 and 1 go together, and you can list them like that. Other people think that looks weird. They want to put them in order, like numerical order. It doesn't matter. So kind of whichever way makes more sense to you. Ben spoke up first, so we'll go with that. 2, 3, 6, 1. And again, maybe that looks out of order to you, but it also looks like Ben paired them up. So either way. Okay, so now we have to list every possible combination of top and bottom. We don't have to put the plus or minus on every one of them. We'll just put the plus or minus out front and know that that goes for everything rather than writing it every single time. Okay, so let's start with the 1. Let's see. So I'm going to put the 1 over everything. So 1 over 2, 1 over 3, 1 over 6, 1 over 1. What's 1 over 1? Let's reduce that one on the fly. That would just be 1. So there's some options. And now I have to do the same thing with 2. All right, what's 2 over 2? 1, but I already have that, so I don't have to write it again. So we got 1 taken care of. 2 over 3. 2 over 6, that reduces. What's 2 over 6 equal to? 1/3, and we already have that. So some of these are like repeats. We don't need to write them again. And then 2 over 1 is 2. So how many possible rational roots did we just list? Gotcha. 1, 2, 3, 4, 5, 6. So you know how to count, but plus or minus means 12. So there's 12 possible roots, but there's only 4 zeros. So not all of these are going to work. There's no way they could. There's only 4 that actually work. But of the rational roots that work, they have to come from this pool of numbers. So again, this is from the land before calculators. If you're trying to factor this thing and you're just trying to guess and check, well, here's your guesses to see what works. Okay, let's test some possible roots, then factor completely and find all roots. Okay, well, test some possible roots. What's a really easy way that we learned in the past few days to test some roots? Say it, I think. Synthetic division. And what will we be looking for when we synthetic divide? And we'll be looking for a remainder of 0. If the remainder is 0, then we found the factor. So 6, -1, 4, -1, -2. Because I'm using that same polynomial from up here. And at this point, we don't know which of those numbers is going to work. So I say let's start with 1, just because that should be an easy one to check and see. So bring down the 6. Multiply, we get 6. Add, we get 5. Obviously be super careful here. Like, this is easy, but easy to mess up. This is not looking good for a remainder. So what does that tell me about x minus 1?
Not a factor.
Not a factor. Well, in the land before calculators, and even, I should be careful how I phrase this. When I started teaching, we did have calculators. I'm not that old. But we would make students do this without a calculator, and so they'd have to guess and guess and guess until they found one or two that works. And the trouble is, if you're lucky and you guess right the first time, this problem doesn't take long. If you keep guessing wrong,
I think it's 1/2.
hold on just a second. There's 4 zeros, there's 12 possibilities, so it's possible that you guess 8 wrong things. I mean, you'd have to be a really bad guesser to do it that bad. But it's possible that you would guess 8 wrong things before you got the right answer. That would be rough. Why do you think it's 1/2, Ben? Just guess? Are you just guessing?
By half. We need to find some way to make it less.
Okay, now you're thinking, and that's what we would tell students when they didn't have a calculator. It's like, look, this is kind of getting out of hand. Maybe we should pick a fraction to make it less to get the numbers down.
Definitely not 2.
So Ben's right in that, yeah, 2 would kind of blow this thing up, so we wouldn't want to try 2. But then we decided, you know what? What's also important is knowing how to find zeros in a calculator. So we're going to sort of cheat to guess. I know. We're going to guess in quotes with some help. So it's not really guessing. We're going to use a calculator. So let's grab a calculator. I'll pause the video here so everyone can grab either the 84s are at the front.
So like these things that we just found, that's what we're. So before whenever we used synthetic division, we did like x minus 1, right?
Yes.
So and then we do it like x equals 1, right? This is the x equals 1.
Those are the. Okay, good question. So before we did synthetic division, a couple more comments on that. We would tell you what to divide by, right? We would just say, hey, use x minus 1. Now we don't. We're like looking for. We want to factor this thing. And so we're looking for factors, which means if we could find zeros, we would know factors because we know how those go together. We don't know which one of these works, so without a calculator, we would just keep guessing. And, I mean, Ben's observation is right. He's like, that 2 is probably not going to work, so let's guess a half or negative 1/2 or maybe negative 1. But you're still random, not random guessing, but you're trying to find 4 out of 12. I mean, eventually you'll get 1, but let's
Not the count the negative and positive instead of broken.
right, that because there's 12 options, and you know at most 4 of them are going to work. So your odds aren't great. I mean, eventually you'd find one. So we're gonna cheat, in quotes, not cheating because I said it's okay, and use our calculator to find a 0. Because if we can find a 0, we can find a factor. So let's go to y equals. And put in 6x to the 4th minus x, 6x to the 4th.
Where did we guess that?
Y equals, top left. I should slow down here then. So y equals button. X is toward the top left right here. There's a button that says X, T, theta, and N.
So we just click that?
You hit that, and it knows which one you want. It reads your mind. Later in life, you might use theta. Unlikely will you use T or N, but X is what you want, and X is what it gives you. Plus 4x squared minus x minus 2. Okay, let me pause for a second, make sure everyone found all those buttons.
Will we have calculators?
So the test is part calculator, part no calculator. So yes. So make sure you know how to do this because you will have a calculator. And you can hit enter. I think we've done this before. Do you know how to find zeros? Like how to find zeros. That means y equals 0. That means x-intercepts on the calculator. There's 2 options.
Do we press enter?
Press enter. The table is a good place to start. So what would you be looking for when you hit table? So second table. What am I hoping to find? I'm hoping to find y equals 0. Because if one of those numbers make y equals 0, then I'll have the 0, which means I can figure out the factor.
Wait, so it is 2? It's 1 third.
I don't see any answers in the table,
Oh, wait, she's not that.
right? Like none of those are 0. So, what you can also do on the table, I don't know if we want to do this or not, although I don't know if this is worth it or not.
That y equals 0 is 0.
My table, there are no y equals 0s. So if your table doesn't match mine, go check your y equals. Maybe I should check my y equals. 6x to the 4th minus x cubed plus 4x squared minus x minus 2. Okay, I feel good about my y equals. My table doesn't show me any zeros. Okay, there's two options here. You can graph it. We'll talk about that one in a minute. No, let's do that one, because that one's more helpful later in your math life. So let's go to graph. And graph is nice because you can see the zeros. How many zeros do I have? 2. Let's see. I can zoom in if I want, so I don't have to. To find the zeros, this is super important. You'll use this in pre-cal. You'll use this in calculus a lot. Your calculator can find zeros. So second calc, and then you got all these options, but you want to find a 0. So you press 0. If you make it that far, the calculator will walk you through what to do next. So either press 2 or press enter on 0. And it says left bound ? That means get your cursor to the left of the 0. So it can only find them one at a time, so don't like put a window across all the zeros. I'm going to get just to the left of this 0 and press enter. So that's my left bound. Right bound means get to the right of the 0. So scroll over until you're past the 0. Again, you're just doing this visually. Press enter again. And then when it says guess, you can just hit enter again. And it thinks for a moment. And there is one of our zeros. Okay, if you got error, you likely had your left bound and right bound maybe reversed, so didn't know how to find it. So let's back up. Second calc, 0. Left bound ? So get your cursor left of the 0. And then press enter. When you do that, it says right bound ? Like how far to the right do you want me to look? So you scroll over to the right. Make sure you're past the 0. If you don't pass the 0, then it's going to look in an area that doesn't have a 0, and it'll tell you there's an error. There's no 0 there. So make sure your left bound, right bound includes a 0. Enter. And for guess, you can just hit enter again. If you want to try to help your calculator out, you can go move your cursor back to the 0, but that doesn't really matter. It saves milliseconds. Okay, if you got 2/3, then your window was, you probably found this other 0. You can only find one 0 at a time. So if you make your window include both zeros, it's only going to give you one of them. Which, I mean, it's fine, you need them both, but you have to make sure that you're finding both of them. So I'm going to do this again for the other 0. Second calc 0. Left bound means get to the left of the 0. Hayden, you with us? You should be doing this because you're going to have to do this later. And I'm not going to answer your question on the test. How do I do this? I'm going to say do it like we did in class, knowing full well you didn't do it in class. Left bound, get to the left of the 0, press enter. Right bound, ? Get to the right of the 0. Go as far right as you like. Press enter. For guess, you can just press enter again. If you want to help your calculator, you get closer to the 0 and save yourself milliseconds.
What happens if we got errors?
No sign change means you didn't have a 0 in your between your left bound and your right bound.
Are you good to the left bound?
All right, so let me do this 0 again. Second calc 0. When you hit that, it asks you for a left bound. That means how far left do you want me to look for a 0? So make sure you're left of the 0. So I'm looking for this 0, that one. So I go to the left of it, press enter. Then it says right bound ? So how far right do you want to look? You have to make sure your right bound is right of the 0, otherwise you don't get a sign change. Like that's literally how the calculator, it's like plugging things in a million times until it hits a sign change. And when it hits the sign change, it knows there's a 0 in there. So make sure you cover the 0 with your bounds. Your guess, you can just press enter again. And then hopefully you know that 0.667 is 2/3. Okay, It's good that you discovered some of the errors. Hopefully you can fix them, Mason.
How do we have 4 zeros in like the factor list and then there's 4 of them, but we don't have 2 and 7?
Okay, that's a great question. So Mason's question was, wait a minute, the calculator says 2 zeros. But earlier we said 4 zeros. Okay, there's a couple of options. The mult thing, the multiplicity, you would be able to see that on the graph though, because a multiplicity of 2 bounces, and a multiplicity of 3 does like a cubic squiggle thing. So good point, but not it. There are other types of zeros that don't show up on the graph. We saw them yesterday. We didn't see them yesterday, but we talked about them yesterday. The imaginary zeros, Mason, is the answer to your question. That means if I found 2 real zeros, and Mason's right, there's still 2 others, they must be imaginary.
Is it 2/3?
Yes, it is 2/3. Okay, so if I know negative 1/2 works, what should I do with negative 1/2 to start to factor it, or start to get a depressed polynomial? Let's synthetic divide. And I could use either one of those, but I'll just start with negative 1/2. What should I get for the remainder? 0. So it's nice using the calculator. Like, I need to synthetic divide to start to simplify my polynomial, but it absolutely should work because it's supposed to be a 0. So let's see if it works. Bring down the 6, multiply by negative 1/2. Careful here. Add, we get negative 4. Negative 1/2 times negative 4 is 2. 4 plus 2 is 6. Negative 1/2 of 6 is negative 3. That makes negative 4. Half of negative 4 is 2. And again, you have this built-in check at the end. You know you're supposed to get a remainder of 0. So if you didn't get a remainder of 0, either you found the wrong 0 to start with, not likely, or you made some little mistake in your synthetic dividing. Okay, that's a depressed polynomial. That's one of the factors. But we can also factor, or we can also synthetic divide with 2/3. And the good news is we can do it on the depressed polynomial, the depressed coefficients. So as we find more zeros, we get an easier and easier thing to deal with. 2/3 of 6. That would be 4. Negative 4 plus 4 is 0. 0 times 2/3.
Mr. Wolf, where did you get the negative 1/2? I only got 2/3.
For the zeros, I mean, you can see on the graph there's 2 zeros. So you have to do the Calc 0 thing twice to get both of those.
So you just like switch the left bound to the right side?
Correct. So your left bound, yes.
So you just switch.
Got remainder 0 again. That's good. Okay, now I need to be careful. I started with 6x to the 4th. I divided by 2 things. So what am I depressed down to now? What power of x goes with this lead coefficient now? Squared. Because we started with a 4th. This one would have been a cubed. Now we're down to a squared. Or again, you could start at the other end, and the first number would be a constant. Aren't any x terms. So that's a much easier polynomial to deal with. Let's set that thing equal to 0. Let's see, if I subtract 6 and divide by 6, I get x squared equals negative 1. So what are my zeros then if I square root both sides? Good, plus or minus I. Got to put this plus or minus on. Don't forget the negative comes out as an I. How many answers do I now have? total? 4. I've got the 2 I found on the calculator. Those are the real answers. Mason was right to be like, wait a minute, supposed to have 4. Where are the others? They're imaginary, so that's why they didn't show up on the graph. Okay, so my factors. Ben?
I have a question. How do you reset the calculator to that value? Just curious.
You would just start over. So second calc 0. Just start from the beginning. And then put your left down left of the leftmost 0.
Well, oh, okay. Never mind.
Okay, so what factor would have led to negative 1/2? 2x plus 1. What factor would have led to 2/3?
2x minus 3. Oh, no.
It's the other way around, right?
Yeah, 3x minus 3.
Again, if you get stuck on those, be careful. I could start with x minus 2/3, multiply through by 3, 3x minus 2. Now the other factor, it didn't say. I don't want i's in my factors, so I'm going to back up to 6x squared plus 1. But if I take the 6 out, I don't need the 6 in there. It's really just x squared plus 1. And the roots we kind of already have, so x equals negative 1/2, x equals 2/3, and x equals plus or minus I. Like, I knew this was a factor, but I didn't really want the 6 in there, so I factored out the 6. And really, the 6 is what used to make these integers rather than just minus 1/2, minus 2/3.
Just like that's like you just like one step before you did the I. Like,
Yes. Okay, so this is similar to what we did solving with factoring, but now we have a little bit of a helper to find one of our factors, or maybe 2 of our factors. And the trick is, you got to find enough factors to get down to x squared. Once you get down to x squared, you can solve any x squared problem, because even if you don't solve it this way, what always works for an x squared problem? What always works for a quadratic equation? The quadratic formula. So you got to find enough zeros to get it down to x squared, and then you're good. So we're still factoring and finding zeros. We're just using our calculator to kind of cheat us along and help us get to the end. Okay, today's assignment, it's that same worksheet. And the good news is there's nothing new tomorrow. We're just going to practice some more tomorrow. So picking up with part 2 with calculator, meaning we can continue to cheat and use our calculator to find some zeros. What's today? Today is Wednesday. Today we're going to say 13 through 19 odd. Maybe we'll have time to do 1 here in a minute. And then tomorrow, it's just more of the same stuff, 14 through 20 even. So it's one of those days where it's like the lesson is on one day, but we get 2 days to work on things because it's kind of complicated. We need to get used to the calculators. Let's see if we can do number 1. Or number 13, excuse me. How many total zeros will there be? 3. How many do I need to find before I can handle this thing without the calculator? If it starts at x cubed, I need to get it to x squared. So I just need to find 1. If I can find 1, I'll be good. So let's use the calculator and see if we can find 1. So y equals 12x cubed minus 20x squared minus x plus 6. I think I'm even going to do the table first, in hopes that I find an integer answer. I honestly don't know if I'll find one or not, but it's easier. Oh well. So no integer answers. Factor completely using integers, show work algebraically, determine all zeros. Okay. So I didn't find any on the table. Let's go to the graph. Oh, how many are on the graph? 3. So I'll find all 3 from the graph. Second Calc 0. Left bound, I want to find them in order. You don't have to find them in order. So left of the leftmost, press enter. I only had to go like one click over to get right of the 0, and then enter and enter again. Negative 1/2. And then I'm going to do the same thing for the next 2. Second Calc 0. Left of the 0, right of the 0, enter. 0.66666667. That's 2/3. Second Calc 0. Left of the 0, right of the 0, guess. 1.5. You could write it as 1.5. I'm going to write it as 3/2. So what? Now I've got my zeros. This is an easy one. I don't have to do any synthetic dividing even. What factor would have led to negative 1/2? Let's see, x plus 1/2. So 2x plus 1. And what about what factor would have led to 2/3? 3x minus 2. I'm kind of showing the intermediate step to make sure I don't mess anything up. And how about 2x minus 3? Let's see if we found everything. Factor completely. We did that. Show work algebraically. Well, we have a calculator, so it's like, maybe, maybe not. Determine all the zeros. We did that. I'm going to mark out the word then, because we went in the opposite order. We found the zeros from the calculator and then used those to factor. Give exact values. That means don't round to 0.67, like write it as a fraction. So 13 was pretty easy because we were able to find all the zeros. The harder ones are when you can't find all the zeros. Okay. Do you guys have calculators at home or not?